Dan Olds here. It's time for another exciting score reveal show in the 2025 Winter Classic Invitational Student Cluster Competition. And we have one of our best mentors up and joining me to reveal the scores and talk about the application from AWS, Evan Bollig. How are you, Evan?
Doing well, Dan. Thanks for having me again.
Oh, glad to have you. This has been great. It's been, is this the fifth one? I think it
Yeah,
is.
yeah.
Yeah, and it's always been an interesting inflection point. You guys take typical stuff and put a twist on it.
Well,
And
we try to bring real HPC, right? So where
yeah,
rubber meets the road, and
yeah,
it gets interesting when you have to think about real world challenges and budgets and things like that. So, we try to give the students exposure to something that they would see in a professional setting.
it shows. It shows. And the first one you did was the open foam miracle,
Hmm.
where a team went from fifth to second and then winning the whole thing just because they thought, wonder if we can coarsen this up a little bit. Yeah, let's try it.
Yeah,
Yep, that was it. And most recently, was that really on
yeah. Last year, yeah.
last
So
year?
we had cryo-electron microscopy, and it's a very relevant topic for a lot of researchers today,
Yeah,
and big pharma is using it heavily, and so it's a great opportunity for the students to get hands-on to the latest technology.
that was a mind bender for him too, if I
It,
remember.
it was well, it's a complex workflow, and Brian and I last year we made the statement that this is what our customers come to us and ask for help on,
Mm-hmm.
and it's
Mm-hmm.
it's um, it is seriously complex to the point that Brian and I have to scratch our heads at times to understand it. So it reinforces with me that these students are fantastic at thinking creatively and they're very capable of doing. And so what I really love about the competition is that we can throw them the the complex challenge that I see and they figure it out and they figure it out in a week.
Yeah, yeah, yeah. And it's great. Let's
It
talk
is.
about what'd you come up with this year?
Yeah, so this year we did weather modeling. Um, it's so
But
as far as
that's not really the challenge.
well, okay,
Well, right. Okay, let's talk on the face of it.
yeah,
It's
yeah,
weather
yeah, okay,
modeling with WRF. Well
right.
known,
So
well used. Yeah.
on the surface, yeah, it's weather modeling. You're running an application that's going to do weather modeling, and hey, that's cool. If I ask you to improve the price performance,
Hmm.
um, some teams went down the path of playing with the parameter set for WRF to try and get the results faster. And that is effective in some cases, but um, that's not the path that most of industry would take.
Hmm.
Most of industry, when we say, give me better price performance for high performance computing, that boils down to give me better hardware. Give me a
Hmm.
different architecture for the compute.
Give me the
And
right configuration
mhm,
that matches up to what that application needs.
right.
Yeah.
So, in putting this together, I reflected on, okay, who are the other mentors and where does AWS really stand unique? And that is all of our hardware is deployed for all of our customers. And they can come in with infrastructure as code and API calls, and they can construct whatever HPC experience they want on the cloud at any point in time. So we gave the students that opportunity and said, you put on the hat of an architect of a sysadmin
Hmm.
and think about how are you going to facilitate better architecture, better price performance for your end users, and then you can flip hats and go be a user and get the best, like the fastest possible run out of the WRF code, and you play both sides of it, and that's what we do every day with our customers,
Yeah.
and so they
And that's
they
what they're doing.
that's what
That's
they're
what
doing.
customers are doing. Yeah.
They went out, and so the students built clusters in different configurations. They tested different hardware. We have over 850 instance types with
Damn.
Intel, AMD, and ARM processors, accelerators, all sorts of different things. And the accounts that we gave the students were real AWS accounts.
Hmm.
So we had guardrails on them that limited the number of cores that they could use.
Because they'd go after them all.
Yeah. Well, and that's the thing.
Yeah.
High performance computing. Um, We talk a lot about culture and how to promote the best type of culture for the industry. In high performance computing, our community is sort of founded on the need to do more work with limited capacity to compute,
Hmm. And limited budget.
limited budget for sure.
Yeah.
Um, Now, to do more, you have to think creatively, and you can always. It's cheaper sometimes to throw more hardware at a problem than it is to ask somebody to think deeply about the problem and change the algorithm, or to change architectures for the code to run on,
To
and
port it
get.
to something else or to
Mhm,
rewrite it completely.
mhm,
Yeah, that's expensive.
right. So in a challenge that says just give me the best performance, obviously you're going to throw more hardware at it. You're
Hmm.
just going to get fastest possible runtime. And we know that if you've scaled vertically as far as you can, and then you start scaling horizontally, eventually you're going to hit that plateau where you no longer see the benefit, the return on value for scaling out. But most applications that these students running, if we told them that they could scale to 1,000 nodes, 10,000 nodes, right? Like they would just do it
Hmm. Yeah.
because at the end of the day, they just want to see it come back with a lower number than the
Yeah.
next team, right? But for price performance, now they have to think about every time you scale horizontally, that's adding cost. And so if you scale by 4 nodes, if you don't see a 4x reduction in your time, your price performance is actually going up.
Hmm.
And
Yeah.
so, with the limits that we put in place, the students they could get the full experience of HPC, tuning performance, changing algorithms, and all of that. But they had to think, how do I get the best possible configuration for this handful of nodes?
Yeah.
And so we have some teams used AMD architecture, some used Graviton, the ARM processor that Amazon produces. Um, we had some people that changed to adaptive time stepping, some that changed other parameters for WRF. We had some that found loopholes um, that got them better price performance. We actually had one team beat me on the price performance. Now,
Nice.
I'm going to throw out protect
Your rep, your
my
street
rep.
cred.
Yeah,
Yeah.
I didn't spend a ton of time on this,
Yeah.
but I spent enough time that when I saw that a team beat me, God, I'm proud of you guys. Like that is awesome. Really well
I do
done.
have to point out you did spend some time getting a damn PhD
Yeah, well,
and
yeah,
you spent some time working in the industry and
yeah.
yeah. So there's
But
that.
so here's the thing. When um, Amazon has HPC specific instance types,
Hmm.
and the configuration that I started the students out with, we put HPC instance types at the front and said, go find me a better price performance. So already you've got the instance type that we feel would be the best generally overall. But now we want
Hmm.
you to go find the best specific to this application and the constraints that we imposed on the account. So the best solution overall turned out to be reducing it to one compute node. No joke.
Hmm.
You don't scale horizontally. You just have the one node, and then you
But
change
with
to a different.
lots of memory. If I remember right, there were hitting some memory bounce. That could have been those teams, though.
That, but that's an option, right? If you
Yeah,
have,
yeah.
we have within our 850 instance types, we've got a class that so C, M, and R are the naming schemes on these. If you go
Hmm.
to an M or an R, it just changes the amount of memory per core
Hmm.
that's in that instance type. So you could just switch to a different class that gives you more memory per core, and then you get to run on the one node. And with adaptive time stepping, an algorithmic change, well, you can get that result back in less than the 4 minutes, 30-second limit that I imposed. And so that team turned out to be 27% better than me on price performance.
Nice.
So
I,
hat
you
tip
know,
to you guys.
I've talked to maybe half the teams since this. I'm
Mhm.
doing my second round of interviews and talking about this since it was the most recent challenge. And one of the things I was hoping for, because in the pre-briefing that you recorded that I sat in on. Um, there were subtle hints towards profiling.
Yeah.
And I was thinking that at least one of the teams would go ahead and just grab a free profiler, profile it, and see what it's doing. Because every application is lumpy. Some need
Yeah.
more memory. Some can't use as many cores,
Yeah.
need faster cores, or lots of slower cores will perform better. They didn't do it.
No,
It's
there were a lot of
too
shots in the
bad.
dark. Hmm.
Yeah, that's kind of what I got, except for Santa Cruz, if I remember right, who said, well, I did notice that when I tried this instance type, that it was topping out on memory. And so I went to that one, and he sort of did a mental profile on a couple of different aspects.
Hmm.
And good, good, good. But it's to me, I think that's the first thing you want to do when you're trying to optimize any app is you got to know where it's bottlenecking.
Absolutely. You've got to think about it strategically. So your time investment to run a profiler is minuscule, small compared to the one team ran um, about 100 different jobs to test different configurations. And I'm not
That's
complaining
good.
about.
Good.
That's good. That's good.
Yeah.
You had them, the instances for 3 days, the account
Yeah.
3 days at a time. Use that time to test all this stuff. But in just one cluster, they had over 100 runs, and um, I asked for the report to include a column that gave justification for why they made the change between types or different configurations, because if you were in a setting with a customer and you're doing these runs and it happens that the time that you're doing the runs is billing to your customer, they want to know
Yeah.
why they're investing in that, right?
Yeah.
But it also those notes start to map out the parameter space and give you a better sense of where you're investing time. And you'll see if you took rigorous notes on all those configurations, you probably walked over a couple of test cases that were exactly the same as before.
Yeah.
And profilers are a way to avoid that. They'll tell you exactly where to focus your effort. You don't have to do a large search space. Good notes will help you avoid that because you can walk back and say, "Oh yeah, I tested this last week, Wednesday, and I don't have to work on that again." Um, so there are a
Yeah.
lot of ways that you can get through with lower budget.
And change one thing at a time, typically, as opposed to
Yeah,
changing a bunch of things at a time.
yeah.
And there was
So,
another, go ahead.
well, I was going to say one of the loopholes that I didn't close intentionally because I wanted somebody to find it. I don't think anybody did. The accounts that were vended out had infrastructure that was already running, as in an EC2 instance that was already sitting there waiting for you to use. And it was counting against the limit on the account. So if you had just terminated that instance, freed up the resources,
Ooh.
you would have gotten one more instance on your scaling, right? Um, or
Uh,
if you had switched regions where there was
uh-huh.
no infrastructure in the other region and the same service limits, but free for all, whatever you want to go after, more, ways to do more scaling. And these are sort of the
They didn't push that wall.
no, but I think about that stuff because um, like I said, HPC, we always sort of have to live with these constraints.
Mhm.
And, some of my heroes in HPC, there's a fun one. Um, Go back and look at the history of inverse square root.
Hmm.
And it boils down to you'll find mention of the inverse square root used in the Doom video game.
I was early on Doom.
Yeah.
Yeah.
Okay. Awesome history of how it's it's not actually a complete inverse square root calculation. It's an approximation, and it's a very clever approximation that is super fast in hardware. And it's a perfect example in my mind of like cutting corners to get a good enough
Good
result,
enough.
but in the least amount of time so that you can unlock other potential. Like that game at the time was the best graphics and the best experience, and
Oh,
it was just
yeah.
amazing, right?
Yeah.
And a lot of it came down to this one particular optimization.
Oh,
That wasn't
yeah,
that long
yeah.
ago, right?
No,
And
no.
I mean, you go back to landing on the moon. I mentioned this in one of the office hours, but NASA landing on the moon, they had computers on board.
Yeah,
They didn't have
not,
what, even close to what you have in your phone right now,
no, no, no,
but
no.
they made it to the moon and back,
Yes,
right? Like,
yes.
how do you do
Orbital
that?
mechanics
Yeah,
burns with systems that aren't as precise as they should have been.
right.
Yep.
So you can
Yeah.
do a ton more than you think if you just challenge yourself and start to think critically about what's absolutely essential and how do I make use of it.
Now
So
there was one other aspect to this that they weren't just doing WRF and getting the best price performance once. They were doing it twice because there was a disaster recovery drill in the middle.
yeah, yeah. So I like I said, I went into this thinking real world HPC,
Hmm.
and it's hard in a week to condense the number of years that I've been in the industry and the number of challenges that I faced. But I can tell you that the most impactful challenge that I ever faced was when I walked into a data center after a heavy storm and it was flooded and like all the hardware was dead. And then thinking through like, oh man, how do we get back up and running? How do we acquire new hardware and get these users on again? How do I go through and file the insurance claim? And,
Oh.
like there are a lot of facets to managing infrastructure that you don't see because our sysadmins are really good at hiding the complexity there. They abstract that
Hmm.
away for us.
Hmm.
But when you pull the curtain, it's a very challenging world. And there's a reason that we have dedicated sysadmins and dedicated end users. And when you find good balance or harmony between the two, that's when you see the best possible scenarios for HPC because you've got like go to your other mentors, right? You get the DOE labs where the most impressive calculations are happening on the most impressive machines worldwide,
Yeah.
right?
And that they scavenge every bit of
Oh, they
power
do.
and utilization. And I think
Mhm.
that's where, you know, non-lab, I think that, every data center has to do that now. That
Mhm.
the costs in power, in cooling, in hardware have gotten to the point where they have to adopt those HPC practices and technologies just to
Mhm.
get by.
Yep.
It's a different world. Now,
It's a very different one.
but in this challenge, this was about as difficult for the students as I've seen in terms of average score. It was just, fraction of a point easier in terms of average score than the quantum challenge. Why was this so hard?
I don't know, Dan. Um,
I mean, there was a
okay, well,
wide range in the scores.
there was. Let me maybe step back and say
Yeah.
how we scored
Okay.
because um, the way I scored this year wasn't strictly on how you measured price performance or performance.
Hmm.
I awarded points for just following the directions. We had that PDF write up of what the challenge was and the
Yeah.
deliverables that were required.
It
So
was pretty clear.
it yeah, I wanted it to be very clear because real world, if I go on contract for a customer, I'm going to have agreed on milestones,
Hmm.
timelines, deliverables, and that's what I have to deliver. That is what I'm being
Yeah.
paid to deliver, right? So these students were given a challenge of like, I need you to give me an infrastructure as code. I need you to give me a report. And in the report, I need a table that has specific column names. And then you can do whatever you want past that. But I need you to satisfy
Yeah.
these checkboxes. And so when I went through and was awarding points for those required pieces, I really started to see the separation in what the teams were able to achieve. The the price performance bit, um, as far as that scoring goes, I held a number of points for um, bonus if you could beat me, and it was just it was So price performance, if you had a column that said price performance and you gave it to me and it was calculated correctly, the ratio, yeah, it
You
matters
got
how
some
you
bonus.
calculate it. Whether it's
Yeah.
price performance versus performance price ratio, matters in delivering to a customer as well. So we had, a 5 point alternative on that, but there was 25 points held for could you beat my price performance, and one team got that. Another team, I actually did award them the bonus because they got so close. I mean, they were like
Mm.
neck and neck with me on price performance, and they used loopholes that I knew were there and I was excited to see. Um, and that moved them up into the core group. But yeah, it really boiled down to just can you satisfy the requirements?
Yeah.
And if so, one team actually commented in their write-up that they were a little disappointed that I gave the HPC 6A as the base template for the HPC for the cluster because their results showed that that was actually the optimal configuration. Now, we had teams that proved that that wasn't the case, that they could find another configuration that was optimal. But for that team, they decided, well, you took all the effort away from us, and we would have liked to have seen you put us initially on, some other type that would be 10 times slower, and then we'd have to work our way back to that conclusion. And that's valid, but um, in real world, you're going to start with a known good
You're going
and
to start with something. Yeah,
see if you can go better, right? And so it really comes down to, start with something that works well and then satisfy the requirements.
makes sense. Well, let's take a look and see how they did.
Yeah,
You ready? Okay.
yeah.
First, though, we take a step backwards. Here's what the teams look like, what the leaderboard looked like before this challenge. And Texas Tech has almost run the table, the Red Raiders, which have not seen that before to this extent.
They're doing
Um,
really well this
they
year.
really, really are very impressive. Um, Roadrunners, Santa Cruz, um, they're still in it. They're close. Nautical Processing got knocked down a slot because of what the Roadrunners and Santa Cruz did on the Oak Ridge Challenge. We still have Fayetteville in the hunt. I really am kind of liking this UC Riverside story. Brand new team, fun to talk to, young, not really much in the way of HPC, but they were all writing their own games. I don't know, elementary school, junior high. So they're enthusiasts. Um, and pretty happy with seeing them come on. Barracudas slipped down a little bit. Lobos, look at that, 100 points on Oak Ridge, and they
Hmm.
had a problem with Linpack, problem size problem, which is
Yep.
too bad because they would be right up there. But that's okay. Now, let's see what happened with the wharf, not wharf challenge. Because it really was finding that right configuration. So the bottom of the board, again, this was deceptively difficult. We had some teams that couldn't get over the hump. The other thing we have to realize is that they all have jobs. They're all going to
Yeah.
school full time and midterms slash finals.
Yeah. Lots of um,
Yeah,
juggling and it's hard. I understand that
it
to get the
is.
results in. And with a disaster in the middle of the week like that,
Uh
we
huh.
had we had some teams that actually reported, they forgot to transport the data out and then they lost the results. So
Yeah,
it's frustrating, right?
it is. It is. And this happens every module. You've got some teams that just can't get it together, and it's understandable, but they still were out there trying and
Hmm.
learning stuff, and
Hmm.
that's what we care about. So we get to the middle of the pack, and we start to see the scores pick up a little bit with the Lobos, the Roadrunners, pretty close together. Um, Fayetteville, Bronco 1 coming in, good. And Riverside, good, good. Um, and again, impressed with Riverside.
Yeah.
Sue, want to see who won? See who got the top three? Here we go. Matadors, Santa Cruz, and the Red Raiders. So these are normalized scores. So the top score gets 100 points.
Yep.
Everybody's normalized off of them. Good job, Santa Cruz. And they're kind
Excellent.
of doing their Santa Cruz thing. Um, they didn't have a good crash course on the exam, but they bounced back. And Santa Cruz seems to follow this pattern year after year where they start at like fourth, fifth, right in there. Then they start going third and second, and they creep up. Slow
Yep.
starts and they creep up.
You know
Good
what?
to
It shows
yeah,
in their work. So I could tell you
does it?
on this module, they were one of the few teams that actually played with Graviton,
They
and
did.
they were
Yes.
so close to seeing the pattern. Um, so they used the R type of Graviton, and they used it in an on-demand configuration. So here was the loophole, or the number one loophole to optimize your price performance was to use spot instances.
Yeah.
So spot, it's the same instance types that you would have in on-demand, but if they're preemptible. So if EC2 says you're going to lose that instance, you have to figure out what to do with your data within 2 minutes, or you lose that run.
Mm-hmm. Mm-hmm.
These are 4 minute, 30
Yeah.
second jobs,
At
right? So
most.
that's
Yeah.
your loophole. You go to Spot because why? Because Spot gives you up to 90% cost savings compared to on demand. And actually, for the R8G instance type that they used, they could have gone 70% cheaper than the on demand.
Wow.
And that would have closed the gap on the HPC 6A, and they would have been out ahead
And
on
it's very unlikely you'd get preempted the middle of one of those runs at 4 minutes, four and a
even if
half
you do.
minutes. Even if you
Even,
do start it again.
I didn't put a spend limit on the account. I
Yeah.
put a core limit on the account. So you just queue it up and let the scheduler retry until it goes through.
Let it find it.
Yeah.
Yeah. Yeah. So good results, but how does it impact the overall? Let's take a look at that. Let's see. Texas Tech is still on top, not challenged there, but you've got Santa Cruz is pulled into second place. Nice job. And definitely within striking distance. Roadrunners are there in third, and that none of these top five teams are really out of the running for anything. Um, you see Riverside surging into fourth. Matadors push into a very close fifth place. So while you see Riverside's looking up, they got to be looking back in their rearview mirror as well. Um, Barracudas, Lobos, Nautical Processing still in this because there's 200 points out there.
Yeah. Well, you look closely at the divide here and
Mm-hmm.
submitting the report, like getting content as a deliverable,
Yeah.
that's your differentiator, right? The teams that
Yep.
didn't submit, they're slipping, and those
Yeah.
that did are juggling around in the top. You know,
That,
it
yeah.
just comes down to, get the results. And I said this in the office hours, right? Just get me something, even if you
Mm-hmm.
take the default configuration, just get me something, and then work on from moving from there.
Get it better from there. And that's
Yeah,
what I tell students in every cluster competition. Do one run, make it work, and put that one in the bank.
yep,
Have that for submission, and then make it a lot better. But
yep.
get something in the bank because these zero scores are killers.
That's what it's going to take you out.
Yeah.
Yep,
And even those teams that didn't submit, they're still out there doing stuff and
correct,
learning stuff. So,
correct.
it's what we want, and that's great. And so, this winning stuff is just to further motivate, it's not the be all end all.
That's
It's
right.
learning it, and they're doing that. I can tell from talking to
Well, and then so this whole thing is great experience exposure before you go apply for a job,
them.
right? And what better way to prove that you have the experience than to have a report that you've written for one of these modules and just be able to point directly to it and say, if you want to read up on what it is that I did, have at it, right?
Yeah.
Like recruiters and interviewers and everybody will find value in that type of thing. So,
Yeah.
you should put the time into writing these reports and do your diligence on fact checking configurations and things like that because that's where you are learning and you deserve credit for what you've learned and the path you've gone down.
Absolutely. And to me, a good interview is where the interviewer sees a whole narrative to
That's
you
right. That's right.
that you spent in this competition roughly 3 months of your own time
Hmm.
outside of classroom, outside of work, of
Hmm.
your own time to learn this stuff, to work in a team, um, to tackle 5 different supercomputers, one of them quantum, um, applications that are real world, and all the war stories that come from that.
Yeah.
And I think that'll make the difference for them being able to do whatever they want to do in this industry.
Yeah.
So there you go. Next up, the last computational challenge is with the Pittsburgh Supercomputing Center, doing some quantum espresso. I think you're a little familiar with that, probably.
I've wrote it a few times. Yeah.
Yeah, yeah. What's it like? Hard, easy? Well, they're going to be basically doing a CPU versus GPU
Yeah.
comparison.
Yeah, and I think that's a really great experience and good exposure to choosing between CPU and GPU.
Hmm.
Um, it's not a tough challenge for building the application. There are dependencies, but we used the SPAC package manager as a tool.
Yep.
I encourage you guys, you'll get coached on how to do the install from Pittsburgh Supercomputing. But if you need it, SPAC is a great way to do that type of build and to track all of your different dependencies if you wanted to test different configurations for an optimal dependency.
Good advice. Good
Mhm.
advice. And then after that, the panel of HPC experts in their final interview, and that's worth just as much as any of these other things. And this is where they put together a presentation of what they've done. We get to question them, and you've done some of these, Evan.
I have. And it's always fun. I get to talk to the students about their experience, and um, it's interesting to hear some of the paths that students like when they start the interview. They say their major and what direction they're headed career pathwise. And then I always like to ask toward the end of the interview, what do you see as the future? Are you going to change more to an HPC track? And man, the number of students that declare, yeah, I would love to do more in HPC. That's the
Isn't that
value to
incredible?
us. It is.
Isn't that the thing is I've talked to them beforehand. I do the interviews, but I've actually done a little formal surveying, and more than says I want to say 75% didn't really know either that HPC was a thing or that they could work in it.
Hmm.
And afterwards, as you've seen in the interviews, most of them are going to have, I would say probably approaching 80% are going to have some element of HPC in what they want to do.
Yeah. Yeah.
And that's pretty cool. But it also shows that this HPC industry really spans a lot more than people think.
Hmm.
Um,
Yep. And a quick tip for the students in years past, what I've seen is we treat it like an interview. So in an interview, I ask candidates to tell me, so as Dan started, tell me about a time when you faced a challenge of some sort, and then you tell me about the challenge. But it's more than just the challenge. I want to hear a story from you about what the situation was, the task at hand, your particular action, what you did as part of that, and then the result, right? We call that
Hmm.
STAR, situation, task, action, result.
Hmm.
And STAR stories are common in industry. We ask them because it gives us a very concise way, concise story of your particular contribution. And in the AWS module this week or past week, I had multiple of you build clusters. So there should be at least two people who come to that meeting and are able to volunteer that information. But I want to know what the rest of the team did as well. I want to know if
Yes.
you were all active or if it was just one of you. I mean, two of you.
Yes. Yes. And I think, I don't know if you were on that interview with one team that had led for a long ways. This was the Open Foam Miracle Year. But we kind of identified one team that had the Larry Bird
Yeah,
of undergrad HPC on it. And it turns out that one student had pretty much done everything.
yeah.
Um, and that doesn't help. That's
It
not
it
good.
doesn't help, but if that one student were to turn their energy back to mentoring the rest of the students, bringing them up to speed, that's a lot. That's very valuable, right? That's heavy lifting on your part, but being the hero and doing all the work, you're a part of a team. Your whole team
Yes.
should be involved and
Yes.
and look for ways that you can be the leader, but bring them up.
And last year, the year before, there was a young woman who did precisely that. And in talking to her, she was reluctant to be a leader and to step forward. She did it through knowledge
Yeah,
and through helping out everyone else to do their stuff.
yeah,
And that's someone who's going to be a superstar in
right.
this industry. I just need to help her get into the right place. Because I think the minute anybody interviews her, um, they're going to latch on
Yeah.
really good. And I see students like that every year. There's a handful, and the rest are going to be great. But
Hmm.
um, it really shows when someone is like that.
Yeah.
So we've got 200 points left, and a lot of things can happen on that leaderboard and have before it can change radically. So keep up on all the HPC Winter Classic news with our official media partner, HPC Wire. Got a website out there. You knew that, Evan? We have a website. Got a
I'm
lot
on
of
it every
stuff on.
day, to be honest. There's a
Really?
lot of great content for
Boy,
us.
it's
Yeah.
coming out slow though. I'm backed up like you can't believe. I'm particularly backed up on social media, but at some point I will be hitting that hard because we've been just busy as all hell doing stuff. So if
Hmm.
you're out on social media, give us a follow. It's not like you're doing anything else. Come on. You're out there reading X, you're out there reading whatever. Follow us. Come on. So stay tuned. We're only getting started. Thank you so much, Evan. Another great year, and we'll
Thank you,
see
Dan.
you. We'll see you in the interviews, I hope.
Yes, and thank you, students. Really,
Yes.
I do appreciate your participation for our module, and it's always great to work with you. So, stay connected. Follow me on LinkedIn. Social media. Dan's on there. Get on board and be active in the community.
Make connections.
Hmm.
All good.